Something just passed through our solar system that is older than the Sun. Not older than you, not older than Earth, older than the star that everything around you formed around. Right now, as you watch this, it's already leaving, climbing back out into the dark, and it is never coming back. For a few weeks, we had it. One object, one look. And what came back from that single look matches nothing in our solar system. It's called 3I Atlas, only the third visitor we've ever caught from beyond our own star. A chunk of ice and rock, maybe 2.5 kilometers across. Small, quiet, the kind of thing that's easy to miss. But by the end of this, you'll understand why a telescope built to see the first galaxies was turned toward this one small, cold thing, and why the numbers it sent back made planetary scientists stop. Here's what actually happened, and that almost didn't happen at all. 3I Atlas was officially discovered in the summer of 2025. But it turned out a brand new telescope in Chile, still being tested, had already caught it 10 days earlier, by accident, before anyone knew what they were looking at. Then, late last year, this thing swung in close to our sun, and for the first time, it got warm. Warm enough that the ice on its surface started turning straight into gas, a thin, glowing cloud around it. And on the 22nd of December, a telescope caught that cloud in the act. Webb split the light from that gas apart, color by color. Because when a gas glows, it leaves a fingerprint, every molecule its own exact set of colors. Webb read that fingerprint. And this is the part where a normal comet story ends. This one was just starting. Start with the water. Every comet has some. Here's the thing about comets, though. Even the strange ones are basically family. We've measured the water in the ones we've gotten close to. Halley, the comet the Rosetta probe chased down and landed on. They're not identical, but they all fall inside the same rough range. Local water, more or less, made in the same cold suburbs we were. So when Webb read the water coming off this one, that's the range everyone expected it to land in. It didn't land anywhere near it. Water carries two kinds of hydrogen, a light one and a heavier one called deuterium, with one extra neutron. In our comets, this heavy kind is rare, a rounding error. In this one, there's about 30 times more of it than in anything we've ever measured here. 30 times. And that heavy water only forms one way. In cold. Real cold. The kind of place where it's around minus 240 degrees. Cold enough that chemistry itself slows to a crawl. So already, before anything else, this thing is telling us, I wasn't made anywhere near your sun. Astronomers, for the record, love it when an object refuses to behave. It usually means it's about to teach them something. So they looked at the carbon next. Same trick, a light kind and a heavier kind. And here the comparison ran out of things to compare it to. Its carbon ratios don't match our solar system. They don't match the cold clouds of gas floating between the stars. They don't match the disks of dust where new planets are being born right now. Nothing we know makes carbon like this anymore. That's the word the paper actually uses, a composition unlike any object in our solar system. Sit with that for a second. We have measured thousands of these things, and this one lines up with none of them. Because that carbon isn't just a fingerprint, it's a clock. The galaxy builds up heavier carbon slowly, over billions of years, as generations of stars live and die. So the less of it something has, the further back it was made. Run this one's numbers through that clock, and you land somewhere that doesn't feel real. 10 to 12 billion years ago. Maybe. The universe was about 13% of its current age. The Sun wouldn't exist for another 7 billion years. The Earth longer still. This piece of ice is not from before the dinosaurs. It's from before the ground the dinosaurs walked on. And yet, here it is, small enough to fit inside a city, passing a planet full of people who figured out how to read it. Now, the part that comes last, because it's the one that stays with you. Webb didn't just find water and carbon. It found carbon, hydrogen, nitrogen, oxygen, sulfur. If that list sounds familiar, it should. Those are the building blocks, the ingredients life is made from. Which means 12 billion years ago, in a frozen, half-formed galaxy, around some star that burned out long before ours was lit, the raw materials for life were already there, already common, already drifting through the cold. We used to wonder if the ingredients were rare. This one quietly suggests they may be almost as old as the galaxy itself. Let's stop and stack it up. The water is heavier than it should be. The carbon matches nothing we've ever seen. The age runs off the end of the scale, and the thing is carrying the chemistry of life. Any one of those, on its own, would be a strange result. All four in a single object we had for a few weeks that will never come back. That's not a comet report. That's a message in a bottle. And we only got to read it once. So why does this matter, beyond being weird? Because until now, everything we know about how planets form, we learned from one example. Ours. One star, one recipe, one frozen leftover pile we grew up inside of. This is the first time we've held a piece of a different one in our hands, and measured it. A direct sample of a planetary system that formed under rules we've never watched up close, in a galaxy far younger than the one outside your window. It's not a dead rock passing through. It's a survivor. The last physical trace of a world that stopped existing before the sun switched on. And for a few weeks, it let us look. Right now, it's still moving, out past the orbits, out toward the dark it came from. It never got closer to us than about 270 million kilometers, close enough to read, never close enough to keep. A few people have wondered out loud whether something this strange could be more than a comet, a probe, a ship. The honest answer, we listened for a signal and heard nothing. The chemistry explains itself without any of that. But here's the part that stays stranger than any of those questions. The people who measured it are fairly sure it was born in our own galaxy, in an old, thin band of ancient stars. And yet, because of how old it is, they can't fully rule out that it came from another galaxy entirely. Sit with that. We may have just held a piece of somewhere the Milky Way isn't. Look up tonight, and the sun will be gone, and the sky will be full of old light. And somewhere in that dark, a fragment older than all of it is still leaving, carrying the recipe for life from a world that ended before ours began. We had one look. We spent it well. And that telescope in Chile, the one that caught this by accident before anyone knew to look, it's called the Rubin Observatory, and it's about to begin a 10-year survey, scanning the sky night after night. The next visitor won't slip past unnoticed. If the universe just got a little stranger for you too, stick around. There's always another one coming. There is more to explore. See you beyond the stars.